Hello guys, so we are going to continue the discussion with respect to statistics, and in this video we are going to discuss about a very important distribution that commonly occurs with respect to data. That is nothing but Poisson distribution. So first of all, we will go ahead and see the definition of Poisson distribution, and then we will try to see whether it is getting applied to a continuous random variable or a discrete random variable. Then we'll try to see when do we use this kind of distribution. Along with that, we'll try to see that how this PMF, specifically over here PMF is created, that is nothing but probability mass function, how these entire graphs are basically created, how this entire distribution is basically created. We'll try to understand that also. And based on the PMF, what is the function that we specifically use in order to create this particular PMF. So to begin with, first of all, we'll go ahead with the definition. So let's go ahead and see this. In probability theory and statistics, the Poisson distribution is a discrete probability distribution that expresses the probability of a given number of events occurring in a fixed interval of time. This is really important. It expresses the probability of a given number of events occurring in a fixed interval of time, if these events occur within a known constant mean rate and independently of the time since the last event. So let me just make you understand this properly by writing some points. First of all, this is nothing but it is a discrete probability distribution. Whenever we say it is a discrete probability distribution, that basically means it gets applied to a discrete random variable. Now, since this is a discrete probability distribution, we specifically use something called as PMF, right? PMF to get this entire probabilities. Okay. The second important point over here is that it expresses the probability of a given number of events occurring in a fixed interval of time. Okay. So here I'm going to go ahead and write it describes the number of events occurring in a fixed interval time, intervals. Okay, fixed time intervals. Now let's take some example in order to understand it. Let's say I have an example, number of people visiting hospitals every hour. So if I have this kind of data, this will follow a Poisson distribution. Okay. Another example will be that number of people visiting banks every hour. So here also you will be able to see that this will specifically follow a Poisson distribution. Why? Because here you can see it expresses the probability of a given number of events occurring in a fixed interval of time, right? So number of events will be occurring in a fixed interval of time. So if you take this specific two examples, number of people visiting hospital every hour, number of people visiting banks every hour. So there is a number of events that is occurring in a fixed interval of time. Okay. So to explain it more properly, I will give you multiple examples and we'll also try to solve some problems with respect to this. Okay. So let's consider that here I'm just going to take a specific data. Okay. Let's say I'll just go ahead and plot a kind of histogram over here. Let's say this is nothing but I'm just trying to show you number of people visiting the bank. Okay. Number of people visiting the bank, or instead of writing number of people over here, let's say I will go ahead and write over here. This is at 12 p.m. This is at 1 p.m. This is at 2 p.m. This is at 3 p.m. This is at 4 p.m. Okay. And let's say there is also one more time we will consider, that is nothing but 5 p.m. So 5 p.m. So these are my time intervals, the fixed time intervals of a bank. Okay. And here we will go ahead and probably write the frequency of people. See over here, we are just going to find out number of people visiting. So instead of frequency, I can also say, hey, how many number of people are visiting in this bank? Okay. At a specific time interval. So number of people visiting. Okay. So the value can be 1, 2, 3, 4. Let's consider this many number of values. 1, 2, 3, 4, 5. Okay. Now let's say that from during 12 p.m. There was a person that visited this bank. In 1 p.m., let's consider that there were 2 people who visited this bank. At 2 p.m., let's say there were 3 people that would visited this bank. Then let's go ahead and, at 2 p.m., 3 people visited. Let's say at 3 p.m. also, 3 people visited. Okay. Let's say 4 p.m., there was 4 people that visited the bank. And in 5 p.m., there was again 1 person who visited the bank. So whenever we have this kind of distribution during this particular, in this way, right? Here you'll be able to see a number of events is occurring in a fixed interval of time. So if I'm just considering number of people visiting hospital every hour, over here 1 people is attending, 1 people is coming to this hospital or bank. Let's say 2 people are coming, 3 people are coming at 2 p.m. So we have some fixed interval every hour, right? And every hour we are seeing that some people are visiting in this specific bank. Okay. Now after this, you know that this is my histogram. But at the end of the day, you'll be able to see that we will be able to create this like a PMF, right? Why PMF over here? Probability mass function, because it is following a discrete random variable. Here you can see the horizontal axis is the index k, the number of occurrences, right? So the horizontal axis over here is the index k, the number of occurrences. Lambda is the expected rate of occurrences. I'll talk about what exactly is this lambda. Okay. But if I really want to convert this histogram into this kind of graph, then we need to use some probability mass function. Now, before going ahead and understanding more about the probability mass function, in this, there will also be a parameter that will be used, which is called as lambda. Now, let's say that if I go ahead and write lambda is equal to 3. So here, lambda is equal to 3 is nothing but it is the expected number of events occurring at a time at every time interval. Now what does this basically mean? If I say lambda is equal to 3, I'm just saying that with respect to this particular use case, at least at every time interval, right, 3 people should be visiting the bank. Okay, and that is actually defined by this lambda value. Okay. So lambda is nothing but expected number of events occurring at every time interval. Okay. So this is the minimum number of events that may be occurring. Okay. Now finally, we will try to take this entire thing and we'll try to see what is the PMF that is basically used over here, the probability mass function, in order to create this graph so that I get the probability on the left hand side. Because what kind of question that I may get? Okay. I will get a question. What is the probability of a person visiting at the 5th hour? Okay, 5 p.m. hour. Okay, so that is the kind of question that I can get, right? So let's say with respect to this, what is the probability of person visiting at 10th hour or 5th hour? 5th hour, you can see it is 0.15, right? For this particular graph. For this graph, you can see for 5, it is somewhere around 0.05. This is the probability, right? For 5, I'm just considering this as 5. But according to my data, I have 12 p.m., 1 p.m., 2 p.m. like that, right? So what is the probability of a person visiting the bank at 5 p.m.? So for this, we use a formula, and this formula, again, we will not go ahead and derive it because our main aim as a data analyst or a data scientist is to understand about the distribution, right? And how we can construct that particular distribution. Say with respect to coding, this will hardly take 3 to 4 lines of code, right? But the main thing is to understand about the theoretical intuition. So the formula is e to the power of minus lambda to the power of x divided by x factorial. Now in this particular case, you know that, let's consider my lambda is equal to 3. This is the minimum number of people coming to the bank at every time interval. That is what we are considering. Expected number of people arriving at every time interval. Lambda is equal to 3. And x is nothing but my value, that is 5. Okay. So if I go ahead and write over here, e to the power of minus 3, lambda is nothing but 3 to the power of 5, and here I will go ahead and divide by 5 factorial. So if I go ahead and do this calculation, I will be getting 0.101. So this is nothing but 10.1% probability, right? Again, your lambda value may change. Okay, it depends on the problem statement, what you can specifically take different lambda value. Now, with respect to every values, we'll be able to calculate the probability by just using this formula. So here, if you see lambda is equal to 1, right? You can actually see that I'm getting one kind of distribution over here, right? With lambda is equal to 4, you can see another distribution over here. With lambda is equal to 10, you will be able to see another distribution over here. Now compare with respect to lambda. As the lambda is increasing, do you see my distribution is moving towards this side, right? It is much more becoming a bell curve. Initially, it started from here. Then we are basically shifting it to here. Then finally, we are shifting it more towards it, right? So this is what is the impact of lambda value. And again, based on different problem statement, you'll be seeing different lambda values. Okay. And again, lambda value is more of a experimentation purpose. Okay. So for every point that you have with respect to the curve, right, you will be able to calculate it, right? So this is what is the question that we can basically derive, right? So I'm just trying to find out, hey, now what is the probability of a person visiting at this hour? Let's say I'll go ahead and write another question. What is the probability of person visiting at 4 p.m. and 5 p.m. So if I have this specific question, then what is the answer for this? It is very simple. I have to calculate the probability of x is equal to 4, right? Plus probability of x is equal to 5. This is what I really need to compute it. Then I can go ahead and just use this particular formula and calculate my final result. And this will basically give me the probability of a person visiting the bank at this hour or at this hour, right? So this kind of questions you can specifically ask. One more question you can say, hey, what is the probability of a person reaching in less than or equal to 3 p.m.? That basically means we are going to consider this, we are going to consider this, we are going to consider this, we are going to consider this. All is that we'll do the summation for this probability, this probability, this probability, and this probability. And that is how we are able to calculate our probability itself, right? So this was about the PMF. Now, let's go ahead and discuss two more important things. One is the mean of Poisson distribution. So the mean is basically computed by a simple formula. So mean over here is nothing but expected of value of x, which is nothing but mu, lambda multiplied by t. Now you need to understand what exactly is lambda. Lambda, I've already told you, expected number of events occur at every time interval. And t is nothing but your time interval. So once we do the multiplication of this, we'll specifically get the mean, and variance is also given by this specific formula. Again, I do not want to derive this. We want to keep our knowledge limited in understanding about the distribution and how it is. Okay. So more, you can probably refer Wikipedia and get more information. It's always a good way that what you really need to do, open the Wikipedia page. You'll be able to see the distribution, you'll be able to see cumulative distribution. So in Poisson, what all things you have this lambda value. The value can be between 0 to infinity. This is the PMF function. This is the CDF function. You can go ahead and explore some of the things, but most of the important things I'm actually telling you in this particular videos so that you can refer it later on, right? But our main aim is basically to understand about different distribution. So I hope you like this particular video. This was it from my side. I will see you all in the next video. Thank you.